This video is going to deal with something called interval notation. Interval notation is used to describe an interval of values along the line. If I'm speaking of every single number on the number line, a graph of that would simply be the number line from negative infinity to positive infinity. And I would go ahead and highlight every single number on that number line. This would represent all of the real numbers that sit on that number line. Another way to represent all of those numbers would be using something called set notation. Set notation involves brackets, and a way to represent all of the real numbers on the number line would simply be by saying, in the set, all real numbers, all reals. Finally, the way we want to talk about today, representing all of those numbers that sit on a number line, would be by using something called interval notation. To represent all of the numbers on the number line from negative infinity to positive infinity, we would use a notation that says, open parentheses, begin at negative infinity, a comma, and then every single number all the way on out to positive infinity. And then another parentheses. I know that this looks like an ordered pair, but it's not an ordered pair. We're using these parentheses in a little bit different context than we do with ordered pairs. We're using them in the context of an open-ended interval. In other words, we don't know what that number is at negative infinity that we're beginning at, but that's where we want to begin. And we don't know what number is at positive infinity that we want to end at, but we know we want to go all the way to positive infinity. So we're using open-ended intervals, parentheses indicating those open-ended intervals, but including all of the numbers on the number line. In other words, this is an equivalent way of representing all real numbers. Sometimes I'm going to represent numbers that are not including all of the real numbers. For instance, in this very first example, I'm talking about numbers that are less than A, numbers that sit to the left of A. That's what's shaded on my graph. Notice there's an open circle on A. The open circle means that A is not part of the set that I want to represent. So in set notation, I would simply say, let's open a bracket, and numbers that are less than A would be X less than A. It's a strict inequality, meaning numbers less than A, not including A. In interval notation, the way I'm going to represent this interval, and it will be a continuous interval, I'm going to say, let's begin at negative infinity. Again, it will be open-ended, and so I'll begin with the parentheses, negative infinity, and then I will say every number up to A, and then I'm going to use a parentheses to close off. The parentheses again means it's an open-ended interval, and A is not included in the set of numbers I'm trying to note. A is not part of the set. In the next instance, if you take a look at the graph, this time I'm talking about all of the numbers that are left of A, less than A, but this time there's a closed circle on A, and so I'm including the A. This is a non-strict inequality, and so in set notation I would say, I'm talking about the set of numbers X that are less than or equal to A. Close off with this set bracket. In interval notation, again, I'm beginning at negative infinity, and infinity is always open-ended. And I want to go all the way up to the number A, but this time I want to include the A. I want to know that A is part of the set that I'm speaking of. And so instead of using the open end parentheses, I'm going to close the end with a bracket. The bracket means A is part of the set that I'm trying to reference. It is a closed-ended interval. In the next instance, this time I'm looking at all of the numbers are sitting to the right of A, and again, open circle on A, so I'm not including the A. In set notation, I would simply say, this time I'm referring to numbers X that are greater than A. Again, it's a strict inequality, not including the a, simply greater than. And in interval notation, I would say my left end is going to begin just to the right of a. So I don't want to include the a. I'm going to say open end, begin at a, don't include a. That's what the parentheses means. And then all of the numbers that go on out to positive infinity. And again, because we don't know what positive infinity is, we're going to use an open-ended parentheses to close off this set, saying we want to go all the way up to infinity. And then in the last instance, again, I'm looking at numbers that are sitting to the right of a, but this time there's a closed circle on a, so I want to include a in the set. And so this will be a non-strict inequality. In set notation, this will be the set of numbers x that are greater than or equal to a. I'm including a in my set of numbers. And so in interval notation, because I want to include the a, I'm going to use a closed end bracket. So bracket a, comma, and then on out to positive infinity, and again, open-ended closing. So far, we have looked at infinite sets, and what we're going to look at right now are going to be some examples of ways of expressing finite sets. All right, so we take a look at this first example here. On the graph of this interval, notice that there's an open circle on A and an open circle on B, but all of the numbers that lie between A and B are shaded. And so we want to represent numbers that are greater than A and less than B. And so in set notation, we would simply say, open a bracket, begin at A, less than x less than b. Strict inequalities, we're talking about all of the numbers that lie from a to b, not including a, not including b. In interval notation, this is going to be a set of numbers that's going to be open-ended because we don't want to include the a and b, and so we'll use parentheses to represent the open-ended interval. And we'll say, open-ended, don't include a, but begin at a, just to the right of it, and then all of the numbers that go to b don't include the b, and so we'll go ahead and close off with a parentheses. It looks like, again, it looks like an ordered pair, but it's not an ordered pair, all right? And so it's the context in which we're using these parentheses that we understand their meaning. This is a representation of an interval of numbers along the number line from A to B. In the next example, I have a closed-ended interval at A and an open-ended interval at B. So I'm speaking of numbers that are greater than or equal to A and less than b. And in set notation, I would say a less than or equal to x less than b. If I want to use that same representation of numbers in interval notation, I would say, let's begin at a, but I want to include the a, so I'm going to use a bracket. Begin at a, include a, go all the way on out to B, don't include B, and so use a parenthesis. Representing numbers from A, including A, up to B, not including B. And in the last example, I have an open-ended interval at A, numbers to the right of A, larger than A, all the way on up to B, numbers to the left of B, including B. And so in set notation, I would be saying A is less than x, less than or equal to B. Close off with my bracket. In interval notation, open-ended interval at A, begin, run all the way on out to B, include B, and close. All of the numbers that are greater than A and less than or equal to B. In this last example, I'm looking at a set of numbers that are not continuous along the number line. Notice that I have numbers highlighted to the left of A with a closed circle on A. I'm including A in my set of numbers. And then I also have an interval highlighted to the right of B, numbers that are greater than B, with an open circle on B, and so I don't want to include the B. If I were to represent this in set notation, I would simply say, looking at the set of numbers, x's that are less than or equal to A, or, and a way to use or in set notation would be by using the symbol U. U means or, the union symbol, or x's that are greater than B, strictly greater, not equal to. And so, reading that set notation, x is less than or equal to A, or x is greater than B. If I want to represent this in interval notation, I'm again going to have to use an or. Remember, interval notation is representing a continuous interval along the number line. So I would have to say, let's begin at negative infinity, open-ended interval from negative infinity. Include all of the numbers up to A. Include the A, and so I'm going to use the bracket to close off the interval, or, the union symbol for or. Begin at B, don't include the B. So open-ended interval, parentheses B, go all the way on out to positive infinity, and close off with the parentheses because it's open-ended. Again, numbers that are less than or equal to A, or numbers that are greater than B in interval notation.